Welcome to the second video for Physics 102 on the mechanics of vector addition, multiplying vectors by scalars, and vector subtraction. This is meant to be a supplement to sections 1.6 and 1.8 in your textbook. Let's start with vector addition. Imagine that we have this displacement vector A, 3 meters x hat plus 4 meters y hat, which on our xy coordinate system looks kind of like the red arrow you see. Also imagine that we have a second vector B, 1 meter x hat minus 3 meters y hat, drawn as the blue arrow. Now these are the two vectors that we would like to add, or written mathematically, A plus B. We're going to call this sum by the variable C. Now we're not going to deal right here with what it really means to add vectors. We're just going to look at what are the mechanics. We'll try to understand the interpretations of vector addition next time in class. So how do we go about adding vectors? Well, we do it component by component. So we'll begin with the x component of the resultant vector C, which we get by adding the x components of A, or 3 meters, plus the x component of B, 1 meter. The sum of these two is 4 meters, which is the x component of C. We then repeat a similar procedure for the y component of C, which we get by adding the y components of the vectors A and B, which in this case means we're adding 4 meters plus negative 3 meters to give us 1 meter for the y component of C. Putting these two components together into one vector, we get our final answer of C as 4 meters x hat plus 1 meter y hat. This is one of the types of problems that you will be expected to do on the quiz next time. Again, don't worry if you don't fully understand what it means to add vectors. We'll deal with that in class. The whole point of this video is just to get you familiar with the mechanics. Let's do another example. A problem similar to this example will also be on your quiz next time. Once again, we have two vectors, A and B, the sum of which we will call C. Only this time, the vector A is 3 meters x hat, and the vector B is minus 6 meters y hat. I would suggest you pause the video and try and figure this out for yourself for a second. Did you get it? You might have been stumped by the fact that the vector A and the vector B each only have one component. And to make matters worse, the component they have isn't even the same. The vector A only has an x component, while the vector B only has a y component. Well, how does one deal with this? Well, the vector A does have a y component. It's just 0, which is why we don't write it. Similarly, the vector B has a 0x component. With this information, we can just proceed as before. The x component of C is just the x components of A plus the x component of B, which in this case is just 3 meters. And the y component of C is once again the y component of A plus the y component of B, which in this case is just negative 6 meters. Putting these two components together, we get the full vector C, 3 meters x hat minus 6 meters y hat. Before we move on to subtraction of vectors, let's take a short detour into a different operation, multiplying a vector by a scalar. As discussed last time, a vector is any quantity with both magnitude and direction. One example of such a vector quantity is velocity. In comparison, a scalar is a quantity with only a magnitude. Scalars don't have direction. Some examples of scalars would be mass and electric charge. Note, electric charge can be positive or negative. So scalars don't always have to be positive, they just don't have a direction. Now it turns out that you can multiply vectors and scalars. As an example, let's assume that we have some object, a box, with a mass of 6 kilograms, moving with a velocity vector v of 4 meters per second in the x direction and negative 5 meters per second in the y direction. we're going to multiply these two quantities together and call the answer by the variable p. Note that the multiplication of the scalar mass m and the vector velocity v yields a vector answer. The quantity p is a vector. We can see this mathematically by the fact that p has the little vector symbol over it. To see how the multiplication is done, let's break our usual rule and put numbers in now. The result we can see is a number, the 6 kilogram scalar, multiplied by something that looks like a sum, the vector. This arrangement is reminiscent of one of the fundamental properties of algebra, the distributive property, where if I multiply a quantity times a sum in parentheses, it's equivalent to doing the multiplications and then adding them, or distributing the multiplied quantity into the parentheses. And this is exactly what we're going to do. We're going to multiply the 6 kilograms times the 4 meters per second to get 6 kilograms times 4 meters per second in the x hat direction. And then we're going to multiply the 6 kilograms times the minus 5 meters per second in the y hat direction to get 6 kilograms times minus 5 meters per second y hat. Carrying out the multiplication and remembering that units multiply just like numbers, we get the final result of p is equal to 24 kilograms meters over seconds in the x direction and negative 30 kilograms meters over seconds in the y direction. This is the type of calculation that you will be expected to do on the quiz. Let's also talk a little bit about what it means graphically to multiply a vector by a scalar. Let's say that I have the vector a represented here graphically by this red arrow. If I multiply the vector a by the scalar number 2, the result graphically is a vector that's twice as long. But what happens if I multiply a by a negative scalar? Well, if I multiply the vector a by negative 1, it just flips the direction. While if I multiply the vector by negative 2, then the direction is flipped, and the magnitude, represented by the length of the arrow, is doubled. So why did we do all of that in between addition and subtraction? Well, it all comes down to the fact that 5 minus 4 can be rewritten as 5 plus negative 1 times 4. Similarly, the vector a minus the vector b can be rewritten as the vector a plus negative 1 as a scalar times the vector b. Thus, subtraction is just a combination of scalar multiplied by vector that we've just talked about and vector addition. As an example, let's assume that we have the vector a, which represents some force. This vector a is 4 newtons of force in the x direction and negative 2 newtons of force in the y direction. Let's also introduce another force vector b, which is minus 3 newtons in the x direction and 5 newtons in the y direction. Now say we're interested in the difference of a and b, or a minus b, and we'll call this result c. Now we know that we can rewrite this expression as a plus the quantity of negative 1 as a scalar multiplied by b. We'll start with a negative 1 times b, which we now know how to do from the previous section. We just distribute the negative 1 to the different components of b. So we have negative 1 times negative 3 for the x component, and negative 1 times 5 for the y component, which gives us a final result of 3 newtons in the x direction and minus 5 newtons in the y direction. Now that we have the vector quantity of negative 1 times b, we're in a position to do the addition. Just as before, we do it component by component. So to get the x component of the sum vector c, we add the x component of a, which in this case is 4 newtons, and the x component of negative 1 times b, which in this case is 3 newtons, which gives us a result of 7 newtons for the x component of c. We then go and repeat the process for the y component, adding the y component of a, which in this case is minus 2 newtons, and the y component of negative 1 times b, which in this case is minus 5 newtons. Substituting in the numbers gives us a result of negative 7 newtons for the y component of c. Combining these two components into one vector, we get our final result of c as 7 newtons x hat and minus 7 newtons y hat. Thus we see that subtraction of vectors is a combination of the two skills already discussed, the addition of vectors and the multiplication of a vector by a scalar, in this case the scalar negative 1. This is another type of a problem that you will be expected to do on the quiz next time. This concludes this video.